We are Group 1041, and this is our E29 final project presentation on mechanical sanitizer dispenser. As we know, the COVID pandemic is still very relevant to this day. Thus, it is very important to clean our hands frequently. Therefore, the hand sanitizer dispenser market is very heated. In 2021, there's around 52 million relevant sanitizer products sold in the US. And in 2028, this number is projected to be around $181 million. While we enjoy the benefit and convenience of electricity-powered hand sanitizer dispensers, we mustn't forget that around 940 million people around the world that still doesn't have access to electricity. Therefore, that's why we designed our fully mechanical dispenser solution.
Our product has advantages over other dispensers on the market. First, it's accessible and reliable. It's low cost to produce. There's no metal parts required, and most of our build is 3D printed. We plan on making our design open source, which will make it easy and cheap for users to repair if needed. Second, there's no need to buy a specific refill brand or bottle. The bottle holder is adjustable to various bottle sizes, so users can install their preferred brand. Third, there's no battery or external supply needed. Electricity isn't always accessible, and it being human powered reduces the need for an external power supply, which makes it more portable, and we don't need a battery that can run out and we have to replace the battery. Lastly, there's no stand needed. A foot pedal can be placed anywhere convenient, and the dispenser sits on a table stably, but the design still allows for a shaft addition to make it stand upright if desired. These images show the hand sanitizer dispenser market and how expensive the current dispensers are right now.
Okay, so here's the overall system design. The idea of the project is actually inspired by cable and cable housing of the bike brakes, which is a very good mechanism for half remote force transmission. The design is consisted of 3 parts: the dispenser that you can put on the table or fix on a mount, a pedal to control, and the cable set for force transmission. The dispenser design actually have gone through 2 versions. The original one is using a lever design, but it cannot fit in different sizes of bottles and could slip on the contact surface between the pusher and the lever. The modified design is using a pulley to solve the problems. The actual prototype of the dispenser is made of plastic and 3D printed. And here's the pedal design. It is consists of 2 parts: an arc to place the end of cable housing and a hinged pedal to pull the inside cable. The actual arc is made with 3D printing, and the pedal is laser cutted by plywood. And here's the final prototype build. In the video, we will demonstrate how it works.
Right. Hello guys, we're Team 1041, and this is our final project for E29. It's a pedal-powered hand sanitizer dispenser. So what we have here is a better solution than those electric hand sanitizers dispenser. The pedal can be placed anywhere on the ground. And we can put the hand sanitizer dispenser somewhere on a table or a shelf, and we can walk to it. And when we step on the pedal, the cable within the housing will drive this pulley to press on the hand sanitizer. Okay, so when I step on it, the hand sanitizer will dispense. Yeah, so gotta keep your hands clean. And something really cool about our project is that we designed a universal fit. So as you can see, this is just a bottle that we got from a supermarket. And the cool thing about this fit is that you can expand it, and you can fit any size of those hand sanitizer bottle in there. So in this case, you don't need to buy like super expensive refill or replacement pot to put in the specific bottle. You can just go get a new bottle and then replace it. Yeah, and also we put a movable pulley in here to make sure that everything glides super smoothly. And down here, this part is inspired by the bike braking housing. So the housing has like a really thin metal insert, and when we put the brake wire inside this housing, it can also glide very smoothly. So this is very good because you can just literally place this pedal anywhere on the floor. See, it doesn't really matter. We can still step on it and still dispense.
Future changes, we thought of 2 modifications for our prototype. So to improve the ability of our prototype to be mass produced, we thought of switching from 3D printing to injection molding. And by switching to injection molding, we would be able to increase the efficiency of our prototype and also improve the strength of our parts. And this is because 3D printing typically doesn't have 100% infill and is produced in layers with bubbles and grooves in between each layer, while injection molding produces one solid part that will be able to handle the constant stress applied by the pressing of our product. For our second modification, we chose to address how to make our prototype more environmentally friendly. And we thought of switching to more sustainable materials, such as aluminum, which can be achieved through CNC milling, as well as cardboard, which can be achieved through a molding manufacturing process. Using aluminum is good because aluminum requires 95% less energy to recycle than to be produced from raw material. And for cardboard, recycling 1 ton of cardboard can save 9 cubic yards of space in a landfill. Cardboard can also be repeatedly recycled. However, the wood fibers in the cardboard get worn down with each recycling process, which is not optimal because we want customers to be able to reuse our product for as long as possible. So if we continue with our idea of switching from 3D printing to injection molding, we can instead employ the use of stainless steel, which we previously did not do for this prototype due to high cost. Using steel is good because steel is the most recycled material in the world. And for each unit of steel that is recycled, that means less material that has to be mined from our earth. Also, stainless steel doesn't degrade, so its strength is always maintained. And the high carbon content in stainless steel provides maximum corrosion resistance, as well as excellent wear resistance and edge retention, which will allow our pedal to maintain condition even after repeatedly being stepped on. Finally, we would like to thank Professor Hayden Taylor and our GSI Sarah Schunkweiler for their support and input during the process of our project. Thank you.